Hello, it's Dr. Tolchinova here with you, helping you with your homework on recurring decimals. So let's read our first question. Express 0.15 recurring as a fraction, and in its simplest form you must use algebra. And so here is a guided solution for us, so we need just to fill in empty spaces. So we say let x be our 0.15 recurring, so and x will be the fraction that we'll find. So since we have 15 recurring, 2 digits recurring, so 15 recurring is 0.15 recurring, means we have 0.15 15, 15, 15 forever. And so if we will multiply our recurring pattern by 100, so we'll move this recurring digits over the decimal place and see what happens. Look, 100x's will be 15.15, 15, 15, and so on and on and on. And if we will subtract just 1x, which is 0.15 recurring, then subtracting 15 point and recurring tail minus just the recurring tail will give me just 15 on the right side, right? 15. On the left side, we have 100x minus 1x is 99x's. Alright, so if 99x's is 15, then 1x will be 99 times less. So we'll divide 15 right, by 99. What else could we do? Perhaps since we've got a fraction, so we might want to simplify it, right? Especially if they ask us in the question in its simplest form. So surely we should look for any common factors of both numbers. So I see that 15 and 99 both can be divided by 3. So I will divide 15 by 3, I'll get 5. And if I divide 99 by 3, I'll get 33. I can't see any further common factors, so that should be the answer, right? So let's look in the next question. In the next question, we need to change the recurring decimal 0.8 to a fraction, and we must use algebra. So this time we have 0.8 recurring, and it is only one digit that is recurring, alright? So therefore what we will do, we're setting up our solution in the same manner as before. So we say let x be 0.8 recurring, okay? And since only one digit is recurring, so we'll multiply only by 10, so we'll get 10x equals 8.888 and so on. Then we'll subtract just 1x from 10x, and that will give us 9x on the left side and just 8 on the right side, so the recurring tail will go away, and so we'll have 9x equals 8. So 1x has to be 9 times smaller, right? So we'll divide 8 by 9. That's it. No common factors can be found between 8 and 9, so that should be the end, okay? Alright, now we've got a bit harder question, although nothing really harder than usual number. The only problem here that we have also the whole part which is not recurring, and then the recurring pattern 417. By the way, if they wrote the decimal points only on top of the 4 and then on top of the 7, that means that all 3 digits are recurring. They will not be putting dots on every single digit that is recurring. So basically 0.417 recurring means that it is 417 repeats itself, alright? 417, 417, on and on and on. Alright, and so we've got our number is 2.417 recurring, and so that means 2 as the whole plus 0.417 recurring, and that's how I would solve it. Alright, I will solve separately this recurring pattern. I will write it as a fraction, and then we'll come back and we'll add 2 whole. alright, to our answer. Okay, this time let's say let our x be 0.417 recurring. Alright, and since there are 3 digits recurring, so I'll multiply my equation by 1000. So I'll get 1000x is equal to 417 whole part dot, and then 417 again and again and again and again, and then I'll subtract 1x. Alright, and that will give me 1000x minus x will be equal to 999x would be equal to 417. Alright, so 1x then will be 417 divided by 919, and that's it. The only thing is left is perhaps double check that this number can be simplified. At the moment I see that the top number is divisible by 3, but the bottom number is not divisible by 5, so very unlikely it will be divisible by anything, so the answer would be x, or not x, but our number converting decimal will be 2 and 417 over 919. Alright, that's it. Okay, what now? Only final question left, not final, just 2 final questions. Alright, so here is a guided solution. Convert the recurrent decimal 0.47 recurring to a fraction. You must use algebra. Alright, so what they're saying, let x be 0.47 recurring. Alright, again we have just 1 digit recurring, so our number x is actually 0.4777, and on and on and on and on. Alright, so what we will do, we might want to multiply by 10x. Alright, that will give us 4.777 recurring minus x equals 0.477 recurring. So if we subtract 10x, so x from 10x, so we get 10x, and on this side we'll get 4.3, okay, and all 7s will go away, and then we'll have 9x is equal to 4.3, so 1x will be 9 times smaller, so we'll have 4.3. Obviously we never should have any decimal in fractions, so we should have only whole numbers. So to get rid of this decimal number, so everything what we'll have to do is to multiply the top and bottom of the fraction by 10. That will give me 43 over 90. There is another way how you can also solve this question. Alright, still if I will set x as 0.47 recurring, I can find 100x, that will be 47 point and then 7777 recurring, right? And I will find 10x, which will be 4777, right, forever. And then what I will have, 100x minus 10x is 90x is equal to 43. X is 43 over 90. So basically the idea of all of these manipulations is to ensure that you somehow multiply by 10, by multiples of 10, alright? You can achieve always the same tail after the decimal point, because at the end of the day, if everything what you need just to get rid of it, alright, so you need to subtract one tail from another, and that's it. That's basically how you will find the fraction. Okay, final question left is prove that 0.827 recurring can be written as a fraction. Everything what we need just to show that this decimal is that fraction. Okay, so let's try. Okay, we have similar situation to the question above. Alright, so let's do the same thing. Basically I will try to achieve the same thing that I have been doing all this time, so I'll try to achieve the repeating decimal tail straight after the decimal point. So if our x will be 0.82727 and so on, alright, then how can I achieve that I will have just 2727 after the decimal point? I first will multiply by 10, right? So if I'll multiply my x by 10, I'll get 10x equals 8, okay, point 27, 27, 27, and so on. I can't subtract 10x or x from 10, because as you can see, if I will subtract just x, right? So imagine I'm subtracting x, 0, 2, 7, 2, 7. If you will start subtracting, you always will be getting something. You see, the digits are not lining up, so you always will be getting reminders, so you actually will not get rid of all this repeating forever digits. So we can't subtract x, right? So perhaps what we can do also, if we will multiply by 1000, then we'll remove not only 8 over the decimal point, but we also remove 127 over the decimal point, alright? So I will multiply by 1000x, so I'll get 1000x is 827.272727 forever, and then I will subtract my 10x's, which is 8.2727 forever, and then I subtract one from another. I'm getting 1000x minus 10x is 990x equals 827 minus 8. Okay, the tail, the recurrent decimal tail will go away, and so we need just take away 8 from 827. 17 minus 8 is 9. 1 is the remaining here, and 8. Okay, so we have x equals 819 over 990. Compare with what we need to prove. We have here the denominator that looks like 110, when here we've got 990. Maybe we can divide by 9, top and bottom, and that's how we can get that. Alright, let's check. If we divide in 819 by 9, obviously we'll divide 990 by 9, we'll get 110, right? But let's see what will happen if we divide the numerator by 9. Okay, 9 doesn't go into 8, but 9 goes into 81, so 81 divided by 9 is 9. Alright, and then we divide in 9 by 9, we're getting 1. Here we are, we've got 91 over 110, and so everything what is required here, we can write as required, alright, as required. That's it, that's the end. Thanks for watching.